So we've seen like how you can use Consul and some different use cases for it. But let's actually take a look at how you can actually start getting your hands on with this. So one of the tools that some of the teammates on my team have built is Shipyard. And what this does is it allows you to actually stand up environments with pre-configured YAML that all runs locally in Docker. So Cody showed that nothing was already running in Nomad for his demo. So I'm going to go a step farther and show that there is actually nothing running in Docker. Oh, not Docker run. So I have no Docker containers running at this time. And so let's take a look at how the terminating gateway works. So we have a bunch of blueprints that Shipyard has, and one of them is Consul terminating gateways. So we can switch into there. And to speed up things, I'm going to go ahead and run this, and then we'll talk about it. So I'm just going to do a Shipyard run. And what this is going to do is stand up an entire environment running all of our things. So let's see what all those things are. So here we have the Consul terminating gateways. And the first thing we have is our network. So we're defining two different networks, a cloud network and a database network. And this is to represent the case where you're deployed in a cloud provider and your database is hosted like RDS or Cosmos DB, and that's running in a separate subnet from your applications. So the next thing we're going to do is deploy Consul. And so we just defined that we're going to run a container with Consul. We give it the config. I'm going to go through this a little bit quicker than usual because of time constraints. And so as we can see, things are actually starting to come up and it automatically opens them for us, which is really nice. But Consul here is going to run on our cloud network. And then we're going to run Nomad. And so we've got a Nomad cluster that we're going to spin up. We give it a version. We depend on Consul because we're going to use that integration that Cody showed off between Nomad and Consul. And we're going to spin this up in our cloud network also. And then we're going to stand up our database. And so what we're going to do is the first thing we're going to do is deploy a terminating gateway container. And we're going to put this on both the database network and the cloud network to represent a single service or a single VM in your cloud network that can cross that network boundary so that when you're deploying this in real life on a cloud provider, you would only have to expose the database to this single instance. And you can do HA and things along those lines with this. So we're just, and then we're also running our database, which is just the MariaDB container with a really super duper secure password here, which we'll copy because we'll need this in a minute. And we're only running the database on the database network. So from the cloud network, there is no direct communication with the database. The other thing we're going to do is after our container starts, we're going to register our MySQL service. So this is actually registering that as an external service. So if we look, we can actually see in here, we define some node metadata that this is external. So this isn't something running in our actual infrastructure. And then we just define our service name and ID and give it a health check so that we can verify it's still online, just like we would any other service. And then inside of our Nomad cluster, we're just going to run a simple job for adminer, which is a basic UI application that provides you access to a database. And so we can actually see here, we've got our Consul cluster, and we can see we've got adminer running in Nomad, got Consul, we got MySQL gateway, Nomad, Nomad client. So Shipyard, if we look at the docs, that's the easiest way to kind of see it. It provides numerous resources. All of these here are the different things it can do. And so what it is it's a very simple tool to actually stand up local environments. And so you can run Shipyard, you build these manifests, if you will, and all of them define things you want running. And so the nice thing is we can actually spin up a Kubernetes cluster. You can spin up any containers you want. You can also spin up sidecar processes that are running next to those containers like you would have in Kubernetes where they share some of the namespace attributes that Docker gives it. We can also define Kubernetes configurations. And so as well as Nomad and Helm jobs.
So is it, okay, so this doesn't run inside Nomad, this runs over it or for it?
Nope.
Or?
This just runs locally for you and it can stand up Nomad if you want to use Nomad. If you want to use Kubernetes, it can stand Kubernetes up.
Okay.
If you want to use only containers, you can use containers.
Okay.
And so it has blueprints. That's the name for them. And so we have a bunch of existing blueprints in the repo on GitHub. And so the one I'm showing is the console terminating gateways. But we also have ones that are just console Docker. And like here, if you look, we can see consoles just being spun up in a Docker container. And we give it an ingress so that we can actually communicate with this. There's nothing that says you have to use Nomad or Kubernetes. It's very build your own with the building blocks and get something running locally on your machine so that you don't have to stand up infrastructure to actually test these tools out. So this is an easy way to get your hands on with them without having to spin up a bunch of infrastructure.
So Shipyard is an application you can run on just about any server. You just do a GitHub clone or something like that, or?
So you can install it. There's a couple ways you can install it. It doesn't even have to be a server. You can do it on your local machine. So all of this is running on my laptop. So I have a Mac, so I installed it with brew. So I just did brew install Shipyard. It might be Shipyard run. Not 100%. Let's see. We have, so we've got install commands. You can also do a curl bash if you're feeling, adventurous. Brew install Shipyard run here. Chocolate to get it on Windows, and there's Debian packages so that you can install it on Debian boxes and RPM, or you can pull down from GitHub the releases directly.
And Shipyard is a HashiCorp tool to utilize to try to play with Nomad and Consul and these other things.
So it's built by some of the developer advocates for HashiCorp. It is not an official HashiCorp tool, but it is built and maintained by the HashiCorp developer advocate team. So now if we take a look, we can actually see here, we can see MySQL is registered now. So if we jump back over, which means adminer will have started finally. So if we look at our README, we can grab that URL. And we'll just open it. And so here we can go, can't do localhost because that gives us the socket. Wrong field. And our super duper secure password. And when we log in, we can see that we've now connected to our database. And if we actually come over and set an intention, right now we don't have any. So we can just create one that shows all services cannot communicate. And when we jump back over here and refresh, we see that the server's gone away. So that shows that the communication is happening through the mesh gateway or through the service mesh and going through the terminating gateway for us. And now we can actually allow admin access to MySQL. And when we hop back over, give it the password, you can see we're connected again and refreshing still works. But we are at time, but there are a lot of blueprints in here. So there's blueprints to actually stand up 2 Kubernetes clusters locally on your machine in separate data centers and federate those like Cody showed using all the different cloud providers. So you can actually test this all locally. And then we also have some already built for just Consul and Nomad that actually stand up an entire environment and show how you can use observability using Jaeger to actually see all the traffic flowing between your applications. So you can actually test this locally for your apps. Perfect.
Yeah.
So we've got that. So let's go ahead and close these. Let's show off the interesting one. So let's tear down, and then as you can see, these are all just Docker containers. So we're running an ingress here to actually be able to communicate. We've got terminating gateways running. We've got the Nomad Docker containers, which is actually running Docker inside of that container so that you can run Docker containers as well without using the one on the host, so you don't have to worry about things getting in the way of one another. We've got Nomad servers, Consul servers, and our database. But let's go ahead and tear this down. All right, so that's been cleaned up. So let's jump over to the Consul Nomad one. Run. So this is going to spin everything up. And so the big thing that this will spin up, close code, there it is. If we look at our Nomad config, we can actually see we're going to spin up an API job, a currency job, which is going to run our currency app, a Jaeger app, a payment app, and a web app. So like if I was doing local development and we wanted to ensure that all of these communication tools worked, we could actually use this to spin these all up locally. As we can see here, we've got things starting to come up. So we can actually watch as all these jobs start. Now we can see they've been scheduled and they are starting to start up. We'll see here in a second, these will actually come to a running state.
So the input for Shipyard, they're just all the standard YAML files or JSON files that I'd be using normally. So
yeah,
any work
so you
I do here is...
Yeah, you get to use the same configs that you would run in production or any other environment. You can template them for development so that they're smaller deployments if you need to, but it's the same exact deployments that you would use anywhere else. Even with the Kubernetes ones, if you look, we actually, for Helm, we've got our console values.yaml that you would pass in, and it runs the Helm apply for you. And then our Kate's config folder, where we're actually just deploying the Kubernetes YAML the exact same as you would manually.
Sweet.
So now we can see all of these are running. So if we hop over here, oh, why didn't the UI come up? Automatically. Fake service. There we go. And so now we can see our fake service here running. We come in on the ingress and it makes a request out to the API. It also makes a request out to the payment service, which makes a request out to the currency service. And so we can just generate a bunch of requests so that we have some more data to go through. And then we can hop over here to Jaeger, which is deployed in our environment, and we can actually select our ingress service here, and we can find all the traces. And so very simply, we're able to see every single request, like the full stack of a request that came in to the stack. And so we've got our ingress call that came in the full time that it took before we returned to the user. The first thing that happened is we made a call to the API service, and then API handled that request and did a service delay just to add some time to how long this takes. And then our ingress went and made a call again upstream to the payment service. And so this one did the handle request and a call upstream. And that made a call out to currency. And we can see that these are all happening over localhost because it's going through the proxy. And so then we can see where currency handled this request and added a service delay, and then the request went to the payment service, and then everything was returned. And then we had a random service delay for our actual ingress service. And that maps the diagram we see here for the request happening with the first one going to API, and then going to the payment service and the currency service behind that. And so this helps you get observability in your dev environments running locally, so you can actually see how your services are reacting. If you're having random slowness, for example, where we've added a service delay of 2 milliseconds, you'd be able to see what's causing your delays if something's taking longer than you would expect. And so for this one, the other piece that we do is inside of Consul, we actually configure Consul with our extra Envoy static config JSON. And so what this is doing is this is configuring some of our endpoints so that we can actually send data to Zipkin. So we manually define Zipkin, which is where we're sending all of this data. And so you're able to just add additional configuration for your instance running, and then start those. And so then we also added default Envoy tracing JSON, which says to go to the collector cluster Zipkin, which is the service here that we've defined, and to send it to this endpoint. And then we've showed off Nomad, but I know there's a lot of people who love Kubernetes. So we can actually jump over here and we can Shipyard run the console Kubernetes example and close these. And so what we're going to get from this one is if we take a look here, so what's going to happen is we're going to define our network, which is just a single network. And then we define a Kubernetes cluster. So we're going to use the K3S driver to actually spin up a Kubernetes cluster because it allows us to bring up a very small control plane to actually run everything. And we're going to give it just one node on the cloud network. And that's all the requirement it takes to get a working Kubernetes cluster right there. The next thing we're going to do is define our Kubernetes configuration. And so we're calling this app just to keep things simple. And we're saying that this is going to deploy all of our YAML that's in this Kate's config directory. So our app.yaml, which is defining our web service, the web deployment, which is just running our fake service. And we're doing our annotations here, just like we did when Cody showed it. And then we've got the deployment for our API. And you'll notice we did not define a service for the API because we're communicating with it only through the mesh. And so we're giving this the annotations as well so that it has the proper configuration. And we're configuring our service to actually run with the Zipkin tracing collector. And then we're deploying Jaeger into our environment. And this is just the Jaeger YAML that Jaeger provides in their Jaeger all-in-one Kubernetes YAML. It's just copy pasted into here to run. We also use Helm to actually bring online Consul. So we pass it into the Kubernetes cluster that we built. And as we can see, things are starting to start up now. And then it also does a health check to ensure that all the pods with release equals Consul came online and started successfully. And for our Helm, we're giving it some simple config to tell it to only expect one instance because we're running this locally. There's no reason to do HA and run 3 replicas because if my laptop crashes, all of them go down anyway. And then just some other basic configs in here to set up a few things. So if we look, we can actually see our fake services running now, and we have our web service that we're hitting, and we're being proxied back to the API v1 over localhost 9091, like we configured with that annotation. And if we hop over here to Jaeger, we're able to see inside of Kubernetes, it's the exact same process. And we're able to see the web request, where the request came into our web service. And that made the call to call upstream, which ends up making the call to handle request for API v1. And the API also had a service delay just to add a little time in how long this request takes. And then we have our web service delay, as a case of like, why is the application randomly slow? Well, here's why. We added a service delay. And then we can see where the handle request gets sent back. And then we have our console environment showing all of our services running. And these are connected with proxy because they're coming from the Kubernetes environment. So we can pull this one down. Oh, is there any specific use case y'all want to see that we can spin up? Do one on the fly?
Like what Nicole's showing here is arguably one of the best ways to actually, as like an administrator coming up in this game and figuring out how to actually do this stuff, one could argue this is the best way to do it. Not everyone has access to infrastructure to build a Kubernetes cluster on. Like not everyone has a HashiCorp expense account to go build 4 public cloud Kubernetes clusters on. Like Shipyard gives people that mechanism to learn this stuff and actually like take these learnings into like real production use cases. And that's kind of what like that home labbing community is all about, is how we take these things and translate them into the enterprise so that we can all feel more successful in what we do every day.
So if you want to, get your hands on with vaults, even though we're specifically talking about console today. What we have here is another blueprint that's actually spinning up Kubernetes and deploying Vault into it. And so you can actually combine these blueprints if you wanted, so that you could actually spin up the full environment like Cody had, where there was Vault running with Kubernetes and Nomad across data centers using separate networks and meshed together through the terminating gateways with the WAN federation and everything. So while this starts, it takes it a little bit longer. We can actually see, you can see we're creating just the cloud network again, creating a standard Kubernetes cluster. We're also spinning up a Postgres configuration, Postgres database. And then with Helm, we're deploying our Vault Helm chart that we have. And then we're deploying some tools just so that we have some tools to work with. You can actually see things are starting to come up now. So we deploy on this one, we actually open a documentation tutorial walkthrough of how to do dynamic database credentials with Vault and Kubernetes. So this actually walks you through all the steps to do this that you need to be able to set this up. And so you can actually do this as a tutorial locally using only Shipyard for all of your infrastructure. Let's see. Yeah. So everything's started now. So we're actually able to set these environment variables. So if we just set this one, and we can actually see now I'm able to get all the pods that are running in this cluster. So we can see we're running the Vault Agent Injector, the Vault pods, as well as the Postgres instance, so that we can do that dynamic secret generation. And we're able to work with this just like it was any other Kubernetes cluster and deploy any YAMLs we want. So we can actually see we could do Vault auth enabled Kubernetes just to enable that. And so now we've enabled the Kubernetes authentication method in Vault. So we're able to interact with these without any problems. And so you could walk through this entire guide and deploy all these. And we even give you the ability to run them, just straight copy paste in the browser just to get these up and going so that you can actually see how this works and get your hands on to these tools as quickly as possible.